All right, another related rates question. This one says the circumference of a circle is increasing at a rate of 2 pi over c inches per minute. Now it says circumference. Let's not forget what a circumference is. Circumference is pi d, or you can say pi times, or 2 pi r, because 2 times r equals d. And it says that dc over dt equals 2 pi over 5. I know it's dc over dt because it says rate. As soon as it says that, I know it's over dt. It's a dc over dt. Inches per minute. When the radius is 5 inches, how fast, okay, so r equals 5. I'm just going to write that down really quick. When the radius is 5 inches, how fast is the area of the circle increasing in square inches per minute? Alright, so the area of a circle, just writing down another equation now, pi r squared. Okay, so we want to find, if I go back and read this, it says how fast is the area of the circle increasing? How fast is it increasing? That's another rate. So we're looking for dA over dt. You know, that's the question wants. How fast is the area increasing? So all we know, the only rate that we do know is how fast the circumference is increasing. We don't know how fast the radius is increasing. Alright, so when the radius is 5 inches, how fast is the area of the circle increasing in square inches per minute? Okay. Alright, let's okay, there's different ways to do this. What I'm going to do is I'm going to try to think like a student would and how they would approach this. The first thing, if I was a student, I would do is I'd say, okay, I need a dA over dt. I need an equation with a dA over dt, and this is where we're going to start because I see an a right here. So I'm going to take the derivative of this with respect to t, so dt, and I'm going to get dA over dt equals, let's see, that's what I get when I take the derivative of a. Because when you take the derivative of a, it just says 1 right there, so you drop the 1, then you subtract the 1, so you would get 0, so a to the 0 power is 1. Then you have to multiply it by dA over dt. You learn that when you learn how to implicitly derive. Okay, now this says pi. Pi is just like a constant. I take the derivative of r, I drop the 2, so it's going to be 2 times pi r raised to the 1 power because I go with 2 minus 1. Okay, and then don't forget to multiply this by dr over dt. Now that is a problem to me now because I don't know what dr over dt is. If I wanted to find dA over dt, I need to know what r is, and I need to know what dr over dt is. Alright, so let's, I don't know, I'll get rid of that guy. Oops, don't want to see those problems right there. Alright, so how am I going to get a dr over dt? This is another equation where I have an r in it, so I'm thinking, why not take the derivative of that one? So let's see. If I have c equals 2 pi r, and I take the derivative of this, d over dt, that would be dc over dt. And on this side, that would just be 2 pi, because remember that's a constant right there. And then I take the derivative of r, which would just be 1, because it has no power. And then I'd put dr times dr over dt. Oh, hey, check that out. There's another dr over dt. Now, if I have a dc over dt, if I could put a number right there, I can get dr over dt and know what that equals. So do we have it? Yes, we do. It's 2 pi over 5, so I'm going to put 2 pi over 5 right there for dc over dt. Remember, that's just like a variable right there. Equals 2 pi dr over dt. And I'm going to divide both sides by 2 pi. Or I can, since this is a fraction, I'm going to think of, instead of thinking divided by 2 pi to the other side, I'm going to multiply this side by 2 pi, because that's the same thing. And this is cool because they cancel out. So I get 1/5 equals dr over dt. Now I get to come over here and plug in what I know what dr over dt is and finish my problem. We have dA over dt equals 2 pi times r. I know what r is. R is 5, it's right here, times dr over dt, which is 1/5. Oh, check that out. That 5 cancels out with that 1/5. And so we get 2 pi. dA over dt increases at 2 pi. Alright, do we see that answer up here? Yay, we're not wrong.